Welcome. The goal of this video is to introduce you to AP topic number 8, which is all about charge. But before we begin, I'd like to take a moment and pause and review the laws of conservation we've had so far this semester. There have been 3. Do you remember them? We've had conservation of energy, conservation of momentum, and conservation of angular momentum. And so we're actually going to start this video on charge with our 4th and final law of conservation, which of course is the law of charge conservation. For an isolated or closed system, the total charge is conserved. Once again, we have this isolated and closed system language, very important when we're talking about conservation. It means that there's just nothing external interfering with the system. This is going to be really helpful for topic 9 when we get there. But what exactly is charge? So it's at its fundamental, it's a basic property of matter. Hopefully you remember this from middle school science, maybe earth science, maybe chemistry if you took that. And this is typically the image that is associated with charges. It's a picture of an atom. It's a very bad picture of an atom. But hopefully that'll trigger your memory with electrons, protons, and neutrons. And so charge is this property that affects the interactions with other objects that also contain charges. And of course, we've got 2 types of charges, positive and negative. And what's one really interesting thing about charge is that we can also have neutral properties. And that's when we have neutral objects that contain equal quantities of positive and negative charge. So a little bit deeper into what charge is fundamentally, we're going to talk about what's called the elementary charge. This is the smallest charge that can be isolated, and it just happens to be the charge of an electron, which conveniently is also the charge of a proton. If you think back to chemistry, you always have equal numbers of protons and electrons in an atom, and that gives it the neutral properties. And then you can go into ions where the protons and electrons don't quite match, and you have the charged atoms, but those are the ions. But at its fundamental level, a charge is just the charge of an electron. So the charge of an electron, this is a fundamental constant, is 1.6 times 10 to the negative 19th C. This C is what we call a coulomb. So that's the unit for charge. All charges are measured in coulombs, but if you have a fundamental charge, an elementary charge, that's the 1.6 times 10 to the negative 19th. I have a really quick and easy exercise for us to try in this video, and it's just called how many electrons? And it's using this idea of this fundamental charge. Okay? And so the first number I'd like for you to consider is 8 times 10 to the negative 19th coulombs. And my question is, how many electrons are in an object that contains 8 times 10 to the negative 19 coulombs? Well, to do this, all we're going to do is divide this number by the elementary charge. If we plug this into a calculator, and we do so very carefully, we should find that it gives us a round number 5 electrons. Now I want you to try it. So I want you to take this number. It's a little different, but it'll work the same way. 8.32 times 10 to the negative 18 coulombs. What I want you to do is pause the video, try it in your calculator by yourself, and then come back to see how you did. Okay, let's see how you did. We're going to take that number, we're just going to divide it by 1.6 times 10 to the negative 19 coulombs, and it should equal 52 electrons. How'd you do? Okay, well let's try one more. So this number is 2.88 times 10 to the negative 19 coulombs. So pause the video, plug it into your calculator, and then come back to see what the answer is. Okay, This one might be a little weird. hopefully you got 1.8 electrons. And right now your brain should be like, that can't be right. And you'd be right. So we just said that an electron, this elementary charge, is the smallest charge that can be isolated. So if we had one electron, that would make sense. But a 0.8 of an electron, that doesn't make sense. You can't have 0.8 of an electron. That's what we mean by elementary or fundamental charge. All objects of charge will have some multiple of this fundamental value. That's why this is called a fundamental constant. And just for your reference, this constant is on the back of your reference sheet. It is listed as, see? It says the electron charge magnitude, and it's at the top of your constants and conversion factors on your reference sheet. I hope you enjoyed this introduction. The next video will go in talking about what happens when these two charged objects, or when two objects of charge start interacting with each other.